Hello. So welcome back. If you're watching this video, it's because you worked on the extra worksheet that I had put up on Canvas for support with qualitative data in chapter 7.3. And let's kind of go through the worksheet together. So this first question here is asking you to look at these three histograms, and we're trying to decide which one refers to which sample size. Ben & Jerry's, Breyers, or Haagen-Dazs. And it says that 65% of all Americans prefer chocolate ice cream to vanilla ice cream. And they did survey and experiments. And what I would hope that you would have gotten from the previous videos and the lesson notes is that the larger the sample size, the smaller the spread. Okay, so if sample size goes up, the spread goes down. And so this one here is going to be our largest sample of 40 with the Haagen-Dazs. And then the next one that is not too spread out, but more spread out than the 40 would be the sample size of 20 of Ben & Jerry's. And then this one up here that's very spread out is going to be the sample size of 10, which is Breyers. And it says, what is the center for all three sampling distributions? So even if they have different sample sizes, their center should all still be at about the same spot, which should be at the 65% that they told us. That's still going to hold true with the central limit theorem, so 0.65. And then it says, compute the standard error for the graph that has the largest amount of spread. So the one with the largest amount of spread is n equal to 10. And so the standard error is the standard deviation of the p hat. And that is calculated by p hat times 1 minus p hat, the square root of divided by 10. And remember that q hat is also equal to 1 minus p hat. And I updated this formula. I think I had just P and Q in the notes. So if you go back to the link, it should be say P hat and 1 minus P hat. So that means the standard error here should be equal to the square root of 0.65 times 1 minus 0.65 over 10. And we can find out what that is in Desmos. If we go down here and find the square root of, and we're going to put 0.65 parentheses 1 minus 0.65 and then divide by 10. And so the standard error for the Breyers ice cream experiment is 0.1508. There it is on my paper down here to the bottom right. So the big takeaway is that sample size increases, the spread decreases. Okay. Question number 2 at the top here says, let n equal 147 and p is 0.13. Assume a random independent sample is drawn with n times p times 1 minus p is greater than or equal to 10. So these are meeting our qualifications for the CLT. So compute the standard error of the p hat. So that means we're going to take the square root of 0.13 times 1 minus 0.13 all over 147. And then we're going to go to And we get our standard error of 0.0277. Okay. Next, it says high blood pressure has been identified as a risk factor for heart attacks and strokes. The National Health and Nutrition Examination Survey reported that the proportion of US adults with high blood pressure is 0.3. A random sample of 80 US adults is chosen. Verify that the conditions for the central limit theorem for proportions are met. So the first thing is we're checking to see if we have a random sample. And it did tell us that right there. So we can check that off. Next up is we are checking to make sure that we have independent samples. And so we are checking to make sure that 80 is less than 0.05 times all US adults. So yes, I'm going to say that the number of US adults is at least 20 times bigger than 80. And the third thing is for normality. So when it's proportions, to check if it's normal, n times p hat times 1 minus p hat has to be greater than or equal to 10. And the sample, the survey said that p hat was 0.3. So we've got 80 times 0.3 times 1 minus 0.3. Is 16.8, and that is greater than or equal to 10, so that gets a check. So those are the three things that you need to explain to me. You can upload if you want to into the quiz, if you'd like to, but you need to be able to explain these three requirements. Part B says, describe the sampling distribution of the sample proportion, give the shape, center, and spread. So we don't really talk about shape, center, and spread necessarily in this book, but we do say that p hat is normally distributed with the center at 0.3 and the standard error at 0.3 times 1 minus 0.3 divided by 1, oh wait, divided by 80. And that's what we're going to use in here. So it says, so I'm going to throw in another question that's not on the worksheet. So what is the probability that the proportion is bigger than 0.32? What is the probability? So you're going to use these in your normal CDF, and you're going to be looking for when the min is 0.32 and the max is a positive infinity. So let's go ahead and do that. And we have the square root of 0.3. Oops. And then it's divided by 80. Okay. And if you wanted to see a really good curve, you can check your magnifying glass, and there it is. So that probability is 0.3481. Making sure that you're rounding to the proper number of decimal places. So that's if I asked you, what is the probability that it's bigger than 32%, 0.32. Now it says, suppose you obtain a random sample of 80 people and 45% of them have high blood pressure. This is very unusual as the probability of this result is only 0.0017. List 3 conclusions you might draw from this result with explanations and context. So the first thing is it could just be a fluke. Maybe we don't have a random sample. And the third thing is maybe the true proportion is not 0.3. Like they told us. Maybe it's something different. Okay. So the key with proportions is when you're using a normal CDF and the inverse norm, you're putting in the proportion that they give you, the p hat, and then your new standard error, which is the square root of the square root right here of p hat times 1 minus p hat over n. And catch me back if you have any questions.